In this video, we're going to go over graphing quadratics in vertex form. The vertex form is f of x equals ax minus h squared plus k. It kind of looks like an absolute value, but with parentheses squared, which means instead of making a v, it'll make a parabola, a u shape for this function. In vertex form, the maximum or minimum of the function is identified using the vertex of the parabola, the point h, comma, k. Notice when the h is taken out, it is no longer negative, it is a positive, so the sign changes. If a is greater than 0, so if you have a positive number, your graph is going to open up, which means you'd have a minimum. If a is less than 0, so negative, your graph would open down, which would make you have a maximum. Because the axis of symmetry goes through the center, the axis of symmetry can be identified from the vertex form as x equals h. So whatever h is, that's what x will equal. Remember, a vertical line is represented by the equation x equals a number. So h would become that number that's in its place. So let's try example 1. I take out the vertex, so negative 3 would become positive 3. Negative 8 stays the same. I'm going to plot that point. 1, 2, 3, down, 1, 2, 5, 6, 7, 8. Now I'm going to use my 1, 3, and 5. There's a 2 in front, which means that it will go by 2, 6, 10. Up 2, 4, 5, 6, 10. 2, 6, 10. There's my graph. Now identify whether the function has a maximum or a minimum. This is the lowest point, so it has a minimum only. Identify the y-intercept. It touches at 0, 10. And I've already sketched the graph. Example 2. I take out my vertex. Negative 3. The positive 3 stays the same. Going to graph that. My pattern is 1, 3, 5. But I have to multiply it by this negative 1/3. It's going to look really weird, but just go with it for now. We have negative parenthesis 1/3. We're going to multiply it by 1. 0.3. Now I'm going to multiply it by 3. You get negative 1. Then we're going to multiply it by 5. And you get negative 1.7. Cross those out because I'm not using it anymore. I go down 0.3 over 1. Then down 1 over 1. Then down 0.7 and another 1. So I'm just going down by the decimals. And draw my parabola. Does it have a maximum or a minimum? This point is the top, which is a max. My y-intercept is at 0, 0. And the graph is sketched. On the last problem, it says reducing the cost of an item can result in a greater number of sales. The revenue function that predicts the revenue in dollars Rx for each $1 change in price X for a particular item is this function right here. The vertex would would be a positive 7, comma, 28,900. That would be my vertex. And then it would go 1, 3, 5, would change to negative 100, negative 300, negative 500. So I don't have a graph. I'm just going to make a little picture. I would plot my vertex and I'd go down 100, down 300, 5. Identify whether the function has a maximum or a minimum. This would be a maximum. What does the maximum or minimum value mean in the context of the problem? So it is the highest point. That means that's where they'll get the maximum revenue or profit. That's where they'll make the most money. So what price increase maximizes the revenue? Well, my vertex is my highest point, so I'm going to look at my vertex. So when I look at that value, that means for every 7, so if I increase it, so for each dollar change in price, so if I change it by $7, then my revenue, $28,900 more. So I would get higher revenue. And that is how we graph and use vertex form.